Let's talk about plywood. I know, it's so common we barely even see it anymore. But it's holding on to a really fascinating secret, a hidden problem with what looks like a perfect solution that for some reason nobody is using. We're gonna find out why.
Okay, so check this out. Right off the bat, the results from this research are just wild. Scientists took a simple substance, melamine acetate, and mixed it into plywood glue. Now look at this chart. The blue bars, that's the plywood strength. It actually went up a little. But the red bars, that's the real story. That's formaldehyde, a nasty gas you really don't want in your home. And with just a tiny bit of this additive, those dangerous emissions, poof, they're practically gone. So stronger and safer? That sounds way too good to be true.
And that, of course, brings us to the big question. If we have this simple, super effective way to make one of the most common building materials on the planet safer, why isn't it in every single new house and piece of furniture? There's got to be a catch, right?
To solve this little mystery, we need to go back to basics. See, the wood isn't the issue here. It's all about the glue that holds it together. Let's take a look at the chemical bond that, honestly, holds so much of our modern world together.
I mean, just think about it. From the desk you're at to the very walls around you, wood-based panels like plywood are absolutely everywhere. They're kind of a marvel, really, turning smaller bits of wood into these big, strong, reliable sheets we can build with.
And the magic ingredient that makes it all possible is a glue called urea formaldehyde resin. Let's just call it UF resin. In the world of manufacturing, this stuff is a total rock star. It's strong, it is incredibly cheap to make, and it dries clear. It's so good at its job that we use about 11 million tons of it every single year.
But you knew there was a but, right? This rockstar glue has a dark side. Over its entire life, it's constantly leaking or off-gassing tiny amounts of formaldehyde, and that can be a really big deal for the air quality inside our homes.
Now, this is not some new, shocking discovery. The industry has known about this and has been working on it for decades. This chart shows a massive coordinated effort since way back in the late 70s to bring those emissions down. And they've done a great job. The levels have dropped a ton, but the real goal is to get them as close to zero as humanly possible.
So the hunt was on for a better bond, something that could keep all the good stuff about the old glue, the strength and low cost, but get rid of those dangerous emissions.
For a while, the standard fix was just to add a chemical called melamine. It kind of worked, but it had problems. It was pricey, and it didn't dissolve very well into the mix. But then, researchers had a clever new idea. Instead of pure melamine, what if they used a salt of it, melamine acetate? The theory was it would dissolve way more easily and be a much more efficient trap for that annoying formaldehyde.
And this is where our mystery gets really weird. See, scientists have known this stuff had huge potential. People were publishing papers about it more than a decade ago. But then, nothing. As this quote points out, there was just silence. No one was actually using it in the real world. Why? So, to find the answer, the researchers behind the study decided, fine, we'll just make it ourselves. Let's follow them into the lab and see what happened.
On paper, the process seems pretty straightforward, like a basic high school chemistry experiment. You mix your ingredients in hot water, you let the solution cool down so solid crystals start to form. Then you filter those crystals out of the liquid and you dry them into a powder. Simple enough, right?
This graph really shows you the patience involved. You heat the mixture up to get the reaction going. Then you just let it cool down, really slowly, over hours and hours. And you can see the good stuff, the crystals, don't even start to form until the mix has been cooling for over an hour.
And it works. The lab process is a total success. They end up with this perfect, fine, white powder. This is it. This is the miracle additive. So if a couple of scientists can cook this up in a lab, what is stopping a giant factory from making tons of it?
Okay, here we go. This is the moment the whole mystery clicks into place. After all the chemistry and all the testing, the researchers finally figured out the real problem, and it had nothing to do with how well the stuff worked. It all comes down to this number, 33.9%. What on earth is that? Well, that's the average yield. It means that for all the ingredients you put in, only about 1/3 of it actually turns into the solid powder you can collect and use. So what happens to the other 2/3? Where does it all go?
This is the incredible twist. It gets washed away. The very property that makes it so good in the glue, the fact that it dissolves so well in water, is its Achilles heel in production. Most of it just stays dissolved in the water, even when it's cooled.
So 2/3 of your expensive raw materials are literally just poured down the drain.
And this one quote just hammers the point home and solves the whole puzzle. To get just 1 single kilogram of the final product, you need a reaction big enough to handle over 46 kilograms of material. I mean, just imagine throwing away 45 bags of groceries to make 1 bag. It's unbelievably inefficient. It's an absolute economic nightmare.
So, what's the lesson here? What does this whole scientific detective story teach us about taking something from a lab bench and putting it into our lives?
Well, the biggest takeaway is this. A brilliant idea that works perfectly in a glass beaker isn't enough to change the world. For any idea to actually make it into your home, it has to make economic sense. The problem here wasn't the chemistry. The science was perfect. The problem was the process engineering. The practical challenge of actually making it at scale without going broke.
And that kind of reframes the whole challenge, doesn't it? The path to safer homes isn't about discovering some new, magical chemical. We already have one that works great. The real breakthrough will be inventing a smarter, more efficient way to produce it.
And that leaves us with one final thought. The potential is just sitting there, written down in a research paper. The science says it can make our homes safer and our air cleaner. The only thing standing in the way is a clever engineering solution. The question is, who's going to be the one to finally build it?